Hi everybody, in this video we are going to talk about types of angles. Let's start with complementary angles. Complementary angles are angles that add up to 90 degrees. So over here we see an angle which is 36 degrees. Here we see an angle which is 54 degrees. 36 plus 54 is 90. So these angles would be complementary because they add up to 90 degrees. Simple enough. Let's move on to supplementary angles, which is just as simple. Supplementary angles are angles that add up to 180 degrees. So here we see an angle which is 79 degrees. Here we see an angle which is 101 degrees. 79 plus 101 is 180. So these two angles would be supplementary because they add up to 180 degrees. Okay, another pretty simple definition. Let's move on to congruent angles. Congruent angles are angles that are equal to each other. This angle is 20 degrees. This angle is also 20 degrees. They are equal to each other. Therefore, we call them congruent. Pretty simple. Okay, now you have to start paying attention a little bit more. Just a little. Okay, adjacent means next to. That's sort of the informal definition of what adjacent means. But now let's get a little bit more technical. So adjacent angles are next to each other. More specifically, they share a common side between them and a common vertex. So let's look at a couple of angles, pairs of angles, which meet this definition. Let's take a look at this angle over here and this angle. This angle we're calling angle X. This angle we're calling angle Y. These are adjacent to each other. So you can see just very informally that they do kind of look like they're next to each other, right? Okay, but more specifically, we're calling them adjacent because they share a common side between them. Okay, so let me take a step back, actually. These two lines over here are the lines that form angle X. And these two lines over here are the lines that form angle Y. And you can see that I went over this line for both of them. Okay, this line is one of the lines that forms angle X, but it's also one of the lines that forms angle Y. So these two angles share a common side between them, and they also share a common vertex. So again, these two lines form angle X. The vertex of where these 2 points meet is right over here. And these two lines form angle Y, where these two lines meet is also right over here, the exact same place where we saw the vertex of the X was, okay? So these two angles share a common side and a common vertex, so we call them adjacent. All right, these two lines over here also share a common side and a common vertex. All right, now these angles also kind of look like they're next to each other. I mean, if these were people and you saw a person standing over here and a person standing over here, you would probably say that those people are next to each other, but they don't. But these two angles over here do not meet the more strict definition of what we really mean by adjacent. So they have to share a common side and a common vertex. These angles over here, they do share a common vertex, but they do not share a common side. This angle is made up of these two lines. This angle, angle V, is made up of these two lines. They do not have a side in common like these angles over here did, okay? So they do not meet the more strict definition of what we mean by adjacent. Okay, these angles are not adjacent because they do not share a common side. These angles over here, they do share a common side right over here. However, they do not share a common vertex. The vertex for R is over here. The vertex for Q is over here. So we would not call these adjacent, even though they kind of look like they're next to each other. They do not meet that more strict definition of what adjacent is. Okay, these angles are not adjacent because they do not share a common vertex. All right, so let's move on now to linear pairs. Okay, linear pairs are a special case of adjacent angles. So all linear pairs are adjacent, but not all adjacent angles are linear pairs. It's a little bit like saying all dogs are animals, but not all animals are dogs. Okay? So let's take a look. Let's read this. So linear pairs are a type of adjacent angles. Linear pairs are adjacent angles that not only they share a common side and a common vertex, but they also form a straight line together. So you can see that this pair of angles over here, angle M and angle N, they do share a common side and they share a common vertex. Okay, so these two lines make up angle N, the vertex would be here. These two lines make up angle M, the vertex would be over here. Okay, same place. So they share a common side, which is this one, and they share a common vertex. So they are adjacent. They are also a linear pair because they make a straight line together. We really should say the outside line. So this line, if we go through angle N and then go through angle M and then shade over this line also, and kind of put these lines together, they make a straight line over here. And if we were to put angle M and angle N together, forget that there's a line between them now. Just pretend that we were erasing this. This angle would be called a straight angle, and that is 180 degrees. Okay, I think we talked about that in the other video, that a full rotation around a circle is 360 degrees. So if we started from here and went all the way around to here, that would be 360 degrees. Like a skateboarder, if they jump in the air and then spin around, you call that a 360, right? Well, now you know why they call it that. If they spin around twice, then it's called a 720, because that's 360 times 2. Okay, but anyway, I'm getting off the topic a little bit. So a full rotation is 360 degrees. Half a rotation would be 180 degrees. Okay, so linear pairs, when you put them together, they make 180 degrees. These are not a linear pair, so these are adjacent still. I don't know why I'm calling this angle M again. If over here I said angle M was this big, let's pick I don't know. Let's pick a different name for that one. Because I said angle M over here was like that, so this one looks bigger. I'm going to just pick a different letter. Let's call that angle S. Okay, so angle S and angle N, they're still adjacent. They still share a common side and a common vertex, okay? But they are not a linear pair because you can see that this, if we shade over the outside lines for these two angles, it does not make a straight line. And this angle over here, if you put this angle together with this one, this is not 180 degrees. So these would not be a linear pair. By the way, what word do you see in the word linear? You see the word line in the word linear. So that's an easy way to remember it. That's obviously where the word linear comes from, is something that is like a line, okay? Actually, when I asked that question, what word do you see in the word linear, I get a lot of funny answers. There are actually a lot of words. Some people say, oh, I see the word I. Some people say, oh, I see the word a. Some people say, what other lines are there? What other words are there? They say, oh, I see the word ear. Oh, I see the word near. So there are actually a lot of words in there. But the word that we're talking about is line. Okay. So these angles do not form a linear pair because the line they form together, this over here, is not straight. All right, so let's move on now. I think I actually already talked about the next thing that we're going to talk about. That's okay. We'll talk about it again. Oh, no. Okay, we're back over to here. We're back here. Okay, so... okay, because linear pairs form a straight line, they add up to 180 degrees. So we talked about that, right? This is a straight angle. This is 180 degrees. So angle N plus angle M here make 180 degrees. Now that makes them supplementary, okay? So let's remind ourselves what supplementary means. Supplementary angles are angles that add up to 180 degrees. So therefore, all linear pairs are supplementary, because if they make a straight line, they must be supplementary, because a straight angle is 180 degrees. So all linear pairs are 180 degrees. Okay, all linear pairs are supplementary, and all linear pairs are also adjacent, but not all adjacent angles are linear pairs, and not all supplementary angles are linear pairs either, because they might just not be next to each other with how they're drawn. Okay, so note that all linear pairs are adjacent and supplementary, but not all adjacent and supplementary angles are linear pairs, okay? So I think I just said that. All right, let's continue now. Angles that are on opposite sides of two intersecting lines are called vertical angles. The angles must be formed by the same lines in order to be vertical. So you can see that angle P over here is formed by this line and this line. Let's just go ahead and extend these lines. So if I extend this line and extend this one also, I can see that these are exactly the lines that form angle Q. So angle P and angle Q are actually formed by the same two lines. Okay, and they are on opposite sides of these lines. By the way, the word intersecting just means that they cross. Okay, so these are intersecting lines. Angle P and angle Q are on opposite sides of these intersecting lines. Now, before I move on to this example over here, just because I know that this confuses so many students, what if I were to talk about this angle over here? Let's just come up with a letter for that. I don't know. I'll call this one G. Okay, angle G over here is not vertical to angle P. These are not on opposite sides of the intersecting lines. Angle G is not vertical to angle Q either. Let's pick another letter. Let's say, I don't know, C. Okay, G and C would be vertical. P and Q would be vertical, but P and C are not vertical. C and Q are not vertical, and so on. They have to be on opposite sides of those lines. Okay. What else? So which pairs of angles would be adjacent here? Let's go back to adjacent. Even though we're really talking about vertical now, let's just quickly go back to adjacent here. Sharing a common side and a common vertex. G and P share this common side and this common vertex. So G and P would be adjacent but not vertical. Q and G, they share a common side and a common vertex. So Q and G would be adjacent, not vertical. Q and C would also be adjacent. C and P would also be adjacent, but these are not vertical. Again, P and Q are vertical, G and C are vertical. Okay, so rewatch this part of the video if you're getting vertical and adjacent confused, because that happens all the time. All right, let's go back to vertical here. So angles that are on opposite sides of two intersecting lines are called vertical angles. The angles must be formed by the same lines in order to be vertical. Let's look at this example over here of angles which are not vertical. So angle Q and angle S are not vertical. Why not? Because angle Q is formed from these lines. And if we extend these lines here, then it looks like this line over here is one of the lines that makes angle S, but not this one over here. The other side of angle S is from this line, right? So angle Q and angle S are not formed by the same lines, and therefore, even though it does kind of look like they're across from each other, they would not be considered, we would not call them vertical angles. Okay, so angles S and Q are not vertical because they are not formed by the same lines. Notice that angle Q is formed by the two thin lines, which I drew over in blue here, while angle S is formed by a thin line, it was this one, and the thick line, which I went over in pink over here. Okay, so let's continue now. Vertical angles are always congruent. Remember that congruent, if we go back up here, this was one of the vocabulary words that we learned. Congruent angles are angles that are equal to each other. So I also repeated that over here. Okay, vertical angles are always congruent. So for example, angle P over here would be congruent to angle Q. Angle P and angle Q are exactly the same size. They're equal to each other. Let's try to figure out why that is. We don't need this down here. Oops. Okay, so let's look at this example. So I'm telling you over here that angle C is 50 degrees. Okay, now you can see that angle C and angle B are vertical. Okay, just again, I'm gonna talk about the difference between vertical and adjacent because that throws so many students off. C and B are vertical. They're across from each other here. C and A are not vertical. These would be adjacent. A and B also are not vertical. A and B would be adjacent. They share this common side and this common vertex over here. Okay, so just a quick review of the difference between vertical and adjacent. So anyway, angles C and B are adjacent. Oh my gosh, I'm sorry. They are vertical. And therefore, if angle C is 50 degrees, then angle B would also be 50 degrees. Okay, so I'm telling you that, but I didn't tell you why. How can we prove that if these two angles are vertical from each other, then they must be the same? Well, we can prove it in this way, that if angle C is 50 degrees, and if you look closely, angle A and angle C, what kind of angles are they? Well, we just said they are adjacent, so yes, they are adjacent angles, but even more specifically, if you remember, we could also say that they are a linear pair. Okay, they're adjacent, but they also form a straight line together. So angle A plus angle C must be 180 degrees. Because remember, we said that straight angles are 180 degrees. So angle A plus angle C must be equal to 180 degrees. So if I know that angle C is 50 degrees, then angle A must be 130 degrees, right? 130 plus 50 is 180. Or what we could do is we could subtract 50 degrees from both sides and see that A is equal to 130 degrees. So we just figured out that angle A is 130 degrees. But what else do we notice from this picture? Well, we notice that angle A and angle B are also a linear pair. They also they're adjacent and they make a straight line together. So if angle A is 130 degrees, well, we can also say that A plus B is 180, okay, degrees. So if A is 130 degrees, then what's B? Well, angle B must be 50 because 130 plus 50 is 180. We could also subtract 130 degrees from both sides of this equation to see that. So B must be 50 degrees. All right, so now I know that B is 50 degrees, but C, the angle that we started with, was 50 degrees. So we just proved that these two angles are equal to each other. And you can use this sort of reasoning every time that you see two intersecting lines. You can say, okay, if I know what this angle is, and these two are a linear pair, so I can figure out what this one is, and then these two are a linear pair, so I can figure out what this one is, and then you can show that the vertical angles are equal to each other. All right, using that reasoning would work anytime. We didn't have to start with 50 degrees. Okay, if this had been 40 degrees, let's say, and we went through that same process, then we would figure out that angle B is also 40 degrees. Okay? So that's why vertical angles are equal to each other. Okay, oops, let me just... Probably should have had this up the whole time as I was explaining that. So anyway, vertical angles are always congruent. They're always equal to each other. All right, so for the rest of this video, I'm going to work on some problems which are similar to the problems that I'm going to be asking you to do in the Deck Toys map. So this is from Skill 4 from worksheets that I used to hand out in class. Determine if angles A and B are adjacent, a linear pair, vertical, complementary, supplementary, congruent, or none of the above. Most questions have more than one correct answer. Circle all correct answers. So let's take a look at problem 1 over here. So this is angle A over here, which is formed from these two lines. And then angle B over here is formed from these two lines. So are they adjacent? Well, what does adjacent mean? Adjacent means they share a common side and a common vertex. Yes, they do, so they are adjacent. Are they a linear pair? Do they form a straight line together? Yes, they do, so they are a linear pair. Are they vertical? No, they are not. They are formed from the same two intersecting lines, but they're not across from each other. Okay, for them to be vertical, angle B would have to be over here, and then A and B would be vertical. Or maybe angle A could be here, and then B and A would be vertical. But these are adjacent, they're not vertical. Okay, so very, very important. You're never going to circle adjacent and vertical in the same problem, because if angles are adjacent, then they're not vertical. If they're vertical, then they're not adjacent, okay? So these are not vertical. Are they complementary? Do they add up to 90 degrees? There's nothing to indicate that they add up to 90 degrees here. No, in fact, we know that they don't add up to 90 degrees because they are supplementary. They add up to 180 degrees. They can't add up to 180 degrees and 90 degrees. How do we know that they add up to 180 degrees? Because they are a linear pair. Any angles which are a linear pair, which form a straight line together, must be supplementary because a straight angle is 180 degrees. Okay? So they are supplementary. Are they congruent? There's nothing to indicate that they are congruent. There's nothing to indicate that they are equal to each other. Are they none of the above? No, we circled a few answers already. Okay, so A, B, and E are the correct answers for this one. Let's take a look at this problem over here. For this problem, these two angles they're not adjacent. They're not a linear pair. These two angles are vertical. They're formed from the same two intersecting lines, and they're across from each other. So that makes them vertical. And what did we learn about vertical angles? We learned that vertical angles are always equal to each other. Okay, remember we could use that reasoning that this and this are a linear pair and this are a linear pair. So if we know what B is, we could figure out what this is. If we know what this is, we could figure out what this is. And then we would see that angles A and B are equal to each other. I'm not going to go through that whole reasoning again, but if you rewind a little bit, you can remember when we did that. So vertical angles are always congruent. So let's circle congruent as well. There's nothing to indicate that these two are complementary. It's possible that they're complementary. So for example, if this is 45 degrees, then this would be 45 degrees also. And then 45 plus 45 is 90, right? So if they were both 45 degrees, then we could also circle complementary, but we don't know that they are 45 degrees. It kind of looks like they might be, but we don't know that for sure. So we're not going to circle complementary. We're not going to circle supplementary either. Vertical and congruent are the correct answers for this problem. All right, let's go ahead and take a look at this problem over here. These angles are formed by the same, so they have a common side. They share a common side. They also share a common vertex, so they are adjacent. Okay, informally, we could say that they're next to each other. Are they a linear pair? No, they do not make a straight line together. This line is clearly not straight, so they're not a linear pair. Remember, all linear pairs are adjacent, but not all adjacent angles are linear pairs. Are they vertical? No, they're not vertical to each other like A and B are over here in this problem. And remember, we also said if angles are adjacent, then they're not vertical. If they're vertical, they're not adjacent. Okay? Are they complementary? Do they add up to 90 degrees? Well, yes, they do. How do we know that? We know that because this symbol over here, I don't think I mentioned this yet, but that little box symbol means that this angle from here all the way to here is 90 degrees. So I know that angle A together with angle B forms a right angle, which is 90 degrees. And by definition, any angles that add up to 90 degrees are complementary. So we will circle complementary here. They're not supplementary. If they add up to 90, they can't add up to 180. Okay, they're not congruent. We don't know that they're equal to each other. There is nothing to indicate that. So adjacent and complementary are the answers for that one. Okay, let's do 3 more examples here. These angles share a common side and a common vertex. They are adjacent. They are not a linear pair. This is not a straight line. They are not vertical. There's nothing to indicate that they're complementary. Right? In fact, we can see that this angle over here is clearly greater than, this is a 90-degree angle. That angle over there is clearly greater than a 90-degree angle. So they can't add up to 90 degrees. They can't be complementary. They're not supplementary either. Okay, if they were supplementary, they would be forming a straight line together. Okay, but they're not forming a straight line together. Well, I should say, okay, to be supplementary, they don't necessarily have to be next to each other, but we already said that they were adjacent. So if they were adjacent and supplementary, then they would have to be a linear pair. Okay, but anyway, so they don't add up to 180 degrees. Are they congruent? See, you can't go just by your eyeballs, okay? A lot of students will look at this and say, oh, they kind of look like they're about the same size, and they'll circle congruent. But we don't know that for sure. So don't just eyeball it and say, oh, they kind of look like they're the same, so I'm going to circle congruent. We do not know that for sure, so we're not going to circle congruent here. The only thing that we know for sure is that they are adjacent because they share a common side and a common vertex, okay? Yeah, that's it. So let's move on to the next one. Are these adjacent? Well, no, they do not. They do share a common vertex, but they do not share a common side. Okay, we actually saw an example like this earlier in the video. All right, so they are not adjacent. They're not a linear pair. They would have to be adjacent, first of all, to be a linear pair. They're not a linear pair. They're not vertical. They're not complementary. They're not supplementary. I mean, we don't know for sure that they're complementary. Again, if this was 45 degrees, or not even necessarily 45 degrees, let's say if this one was 40 degrees and this one was 50 degrees, then we could say that they're complementary because 40 plus 50 is 90, but we don't know that for sure. So we can't circle complementary for sure. We can't circle supplementary for sure. We can't circle congruent for sure, right? Even though they kind of look like they're about the same size, we don't know that for sure. So we can't circle any of these. So for this one, we would just say none of the above. Okay, and then finally, for the last problem, these share a common side and a common vertex. They are adjacent. They also make a straight line together, so they're a linear pair. They are not vertical. They're not complementary, but anything that's a linear pair must be, any pair of angles that's a linear pair must be supplementary because together they make 180 degrees. Okay, so we'll circle supplementary also. Okay, we're not going to circle congruent here. So that's that. Let's move on to a few more problems. We're going to do a few of these problems together, and I think that's going to be it. Okay. So find the measures of the missing angles. What are we going to do here? I think we'll do 6 of these. So we have got plenty of practice here. Find the measures of the missing angles. All right, well, I know that 100, this angle over here and this angle they're adjacent, they're also a linear pair, right? They make a straight line together. So if this one is 132, then what is C? Well, I know that 132 plus C must be equal to 180. So what does C have to be? Well, I could just subtract 132 from both sides, and I would get C is equal to, what would that be? 48, right? 132 plus 48. 132 plus 48 is 180, okay? So C would have to be 48 degrees. Where it says M and then this little triangle thingy and then C, that just means the measure of angle C. So how big is angle C? All right, so it's 48 degrees. I also know that these two angles together also form a linear pair. So if this one is 48, then what is this? Well, I'm asking myself 48 plus what is equal to 180? And really, we already know the answer to that. It's got to be 132, all right? We just figured that out already. So angle B must be 132 degrees. So let's put 132 degrees over here. And we also could, well, you could have figured that out just by saying that angle B and this angle over here, 132 degrees, they're vertical to each other, so they must be congruent. So if this is 132, then this must also be 132, okay? And we could use the same reasoning over here. You could either figure out what A is by using the linear pair reasoning. So for example, this angle and this angle together must be 180. You could do it that way, or you could say to yourself, well, C and A are vertical, and therefore they're also congruent. So if C is 48 degrees, then A must also be 48 degrees. So let's write that the measure of angle A is 48 degrees. All right, let's move on to the next problem. Over here, we see this symbol again, which is telling me that from here all the way around to here is 90 degrees. So if this is 30, then what's the rest of it? What's angle D if together they make 90? D must be 60, right? Because 90 minus 30 is 60, and therefore 30 plus 60 is 90. So if D is 60 degrees here, then everything makes sense because 30 plus 60 is 90, and we can see from this symbol here that this is a right angle over here, so it has to be 90 degrees. All right, moving on. Over here, well, this is a simple one. So this and this, they are a linear pair. So if this is 20, then I'm asking myself 20 plus what, right? E is the what here, is equal to 180. Well, E has got to be 160 because 20 plus 160 is 180. How did I figure that out? I figured that out by doing 180 minus 20. 180, okay, so we could subtract 20 from both sides. I'm not going to do that right now. We already did it before. You saw us do examples like that. So I'm just going to put 160 over here. All right. Now over here, we can see that angle G is formed by this line, which I extended over here, and also this line, which I'm going to extend over here. Okay, is angle G vertical to this 20-degree angle over here? Here's angle G. Is angle G vertical to this angle? No, it is not, because they do share this side, but not this one over here. This side over here has nothing to do with angle G. Remember, for angles to be vertical, they have to be formed by the same two lines, and these are not quite formed by the same two lines. Is angle G vertical to this angle from here to here? No, for the same exact reason, okay? But angle G is vertical to the angle that goes from here all the way to here. Okay, now how large is this angle? Well, that's pretty easy to figure out. We would just add 20 and 21, which is 41. Okay, so I know that angle G is vertical to this 41-degree angle over here, and vertical angles are congruent, they're equal to each other, and therefore angle G must be 41 degrees. Now I also know that angle G and angle H form a linear pair. So 41 plus 108, 41 plus angle H is equal to 180. So what's angle H? Well, if we do 180 minus 41, we would get 139. So angle H must be 139 degrees. We could have used the same reasoning over here with angle G and angle F. They also form a linear pair, so they add up to 180 degrees. Or we could say that H and F are vertical. So if I know that H is 139 degrees, then F must also be 139 degrees. Okay. Over here, all three of these lines put together, sorry, not lines, angles. All three of these angles put together add up to 180 degrees. Okay, so 46 plus 50 plus angle I equals 180. 46 plus 50 is 96. So from here to here is 96 degrees. I want to figure out what the rest of it must be. What does angle I have to be so that this plus angle I is 180? Again, we've done this before. To figure that out, we would just subtract 96 from 180. So angle I would have to be, what would that be, 84 degrees, right? Okay, can't take 6 away from 0, borrow from. Okay, 10 minus 6 is 4, borrow from the 1 now. 17 minus 9 is 8, right? So I is 84 degrees. Okay, over here, these two angles are together make 160 degrees. Okay, I can see that this 160-degree angle is vertical to angle J, so J must be 160 degrees. I can see that angle J, whoa, that was really bad. I can see that angle J and angle K are a linear pair. So if J is 160, K must be 20. Hopefully you understand by now why K must be 20. And then K and H are vertical to each other. So if K is 20, then H is also 20. Okay, so that was a whole bunch of problems. I think I probably did more problems than I needed to there. But that's okay. You have more to study from. So I'm going to end the video there, and have a great day.